All right. Thanks, Kathy. Um, nice to meet everyone virtually. My name's Rob. As Kathy said, I have been with AWS for about 4.5 years now, going on 5 years. So I have worked on many different services and aspects of AWS over that time. What is always a concern and a question, no matter what technology stack you're working with, is how do I make sure my apps are running and available when my users need them to be? So, um, what I will focus on today is how we can approach answering that question with the AWS Resilience Hub service. I will walk through a brief kind of level setting out of terms that we'll use and that you'll see used throughout the service. I'll go through brief overview of what the service is, how it works, and then I'll get into the console and walk through some demo apps that I have set up. And then if you are interested in incorporating this into your environment or just experimenting more, I'll give you some next steps. We'll have some time for questions um, as well. I guess as we go, if you have any questions, throw them in the chat and we can open up the floor for discussion at the end, or I guess as we get into the demo portion. So, as everyone has probably famously heard, everything fails all the time. So says Werner, the CTO of Amazon. So this is a quote frequently used to signify, hey, don't forget, it all looks good when it's running, but what's going to happen when something breaks, and how are you going to approach that? So we center on the term resilience, and you can start by breaking that down into two main paths. High availability is really about how your service responds to or what its resistance to common failure modes is, and how you can quickly respond to those and react to keep a workload up and running. When when high availability is not achieved, essentially for failures that are not accounted by high availability scenario, that is where we start talking about disaster recovery and restoring from a backup or some other approach. In both of the approaches, it's also important to have a continuous improvement mindset in a couple ways. One, the resources in your applications can be changing frequently, and because of that, one, there's an opportunity to constantly evolve and improve the resilience of the application that you're working with, but also continuous improvement in that the whole process can be integrated with your CI/CD, with your development workflow, so that you can understand and respond to changes in the application or changes to the resources quickly and proactively, rather than hearing from your customer or someone else indirectly. So the ability of workloads to respond to and quickly recover from failures is what we are focused on.
Hey Rob, can I ask a quick question?
Mhm.
If you're able to go back one slide. So I used to work in the backup and recovery space, right? And we used to get a lot of confusions from customers about the difference between availability and DR. So the thinking was often, well, okay, so, there's two data centers in the AZ, so it's redundant. Why do I need DR? So do you mind briefly touching on that?
Sure. I mean, there are just scenarios that lead to the need for a recovery. So it could be anything from an actual natural disaster to some type of virus or ransomware, or something that means high availability, which just, for example, could mean ensuring that you have a workload deployed to multiple availability zones. Well, if the whole um, region were unavailable, or all of your applications within that were compromised for whatever reason, and you needed to stand up a new environment in the same region or in a different region, there's many reasons for needing to do a recovery. So in general, it's HA and DR are part of the comprehensive approach to being able to ensure the uptime and the availability of your application, but also ensure the ability to retain your data and recover in terms of a more catastrophic failure. That answer your question, Kathy?
That's perfect. Thank you.
Sure. So, what, how does that translate to applications? And what are we really concerned with? Two primary things: downtime and data loss. So, um, when we start talking about application resilience and what is the appropriate HA or DR strategy, um, the first thing that you'll likely get back is questions. Well, um, what is your tolerance for downtime? What is your tolerance for loss of data? And it immediately becomes a question of what type of workload are we talking about? What type of data are we talking about? Is this a banking system, a payment gateway? Is this a medical information system? Or is this a developer sandbox machine, a test environment, um, or just a meeting scheduling assistant tool used by some departments? There's many variations of the applications that we're running, but we can abstract that in terms of how much data can you afford to recreate or lose, and how quickly do you need to recover from downtime. And the big driver of that is usually, well, what's the cost of the downtime if this is a development system versus your production e-commerce system or payment gateway? There's going to be a big difference in the cost. And that's typically what is going to drive your recovery time and recovery point objectives. If you are, again, in a payment um, banking system, it can't afford any data loss, then that is going to drive decisions around how we store data and how we recover. Um, the same goes with downtime in terms of strategy. And so you you now know, okay, I need to figure out my recovery time and my recovery point objectives, but what are the options in general on AWS, and what do I have to pick from, is essentially the next common question. And rather than just saying, randomly pick a number, I think it helps to center your thoughts around this, around capabilities in your AWS environment. So we'll focus more on the active passive strategies. When you're in a multi-site active active, that's kind of a different animal and probably less common than the other approaches. What we're more commonly looking to do is come up with the right balance of active passive strategies depending on the applications and the environments that we're talking about. So in this context, you can understand the ramifications of saying, well, um, I need a 1 minute RTO and RPO. Well, you can immediately see, well, backup and restore is not going to work. We know that's going to take hours to restore backups and deploy services. And even the pilot light strategy is going to take tens of minutes. The pilot light is going to mean your data in general is live, but that could be a mirror of your production data or a seed of the data, but enough to run the application. Whereas the application, like your services or your application servers, might be there and idle and just need to be started up. But that way, they're not incurring costs. yet they can be quickly enabled and started up. The next option would be, well, if I don't have time to wait for my application servers or my containers to start up for tens of minutes, then I may look at the warm standby strategy where I have that data, but I also have my application or services running in a reduced capacity. So I might have a container or a small footprint running, not my fully scaled production environment, knowing that when I want to, I can quickly scale that environment up. But it is running within minutes, generally just through some routing changes without having to launch and boot up new resources. So starting from this picture, you can kind of start with, almost anyone, if asked, will say, "Oh yeah, I want near real time. I want everything immediately available." And then if you look at the costs or explain the cost, and then it becomes usually, unless it's a mission critical system, it's hard to justify that cost. But then if you can explain to someone, well, here's what can be done for X cost in 15 minutes versus here's what could be done at another cost level. Um, and this could be restored in an hour or 4 hours. This is where it becomes more dependent on your resources and what you're deploying. But you can start giving general guidance to your customers to explain the balance between recovery time, recovery point, and then the ultimate cost for that solution. And so keep this in mind. There's a good blog series that I can share at the end that I like that talks all about the disaster recovery strategies and different considerations around this. But this picture really sums it up. So how does Resilience Hub help with this? And what is Resilience Hub? Resilience Hub is a service that gives you a central place to assess and evaluate the resilience posture of your applications. It is automating the resource inspection process by using infrastructure as code, and you have a few options I'll show you there. It will inspect your resources, group them together logically, and then give you recommendations that you can choose to implement or not. When you do implement any of these, you have all of this advice shared with you in a dashboard so you can view across all of your applications the policies you have in place. And then you can run repeated automated tests against that environment using the AWS fault injection service to give you the ability to simulate things like, oh, what would happen if one of my availability zones is no longer available? Simulate that scenario and test out the actual application in your environment, log the results, and then record the test. So you have both the ability to register your applications and monitor their resilience posture, and also to test that on a continuous basis through these automated disruption types. So this kind of connects back to your question, Kathy, on why might you need one strategy versus another. These are the common disruption types that you can simulate through the fault injection simulator service. So it ranges from your application has a problem with it to the servers that it's running on. There could be a failure in the equipment in the data center. There could be then an issue with an availability zone itself, a power issue or a weather issue, or an entire region-wide failure, like a technical failure or something that would drive something at that scale. So you can simulate all of these types of scenarios within the service and then get real-time feedback on the results. There is a set of supported resources in Resilience Hub. This is growing. At the same time, there's hundreds of services, so not all of them are covered. I would say most of the core compute networking database storage services, and then a lot of the serverless focus fall under other, or DR focus like AWS backup or um, Elastic Disaster Recovery. So there is a full set of supported components in the documentation, but here's the many of the main supported components. So how do we use Resilience Hub? I'll walk through a demo that I have. But the process that I will walk through is we'll first define our targets. So we'll add an application to Resilience Hub. It will perform smart resource grouping so that um, related compute components, related database components, related networking components are going to be grouped together because we know that these resources are tied together for resilience purposes, right? So we will target our infrastructure as code or our EKS cluster. And once the resources are consumed and grouped, you have the ability to automatically assess the resilience. That will give you recommendations, which you then have the opportunity to go implement. And then through Fault Injection Simulator, you can test out the results of those changes and monitor them over time through that CI/CD pipeline type of integration. Uh, you will get a score in the end, so that you can kind of get a simple single number view of how your resilience looks across the full application. And the final nice thing that the service does is it'll track drift over time. So if there are changes made in the environment, it will alert you of that. You can then reassess, rescan, understand if that change was intentional or not. But it's similar to CloudFormation drift detection, if you're familiar with it, that is just letting you know that a change has occurred in your environment. Uh, Let me know before I switch over if there are any high-level questions about Resilience Hub. Otherwise, I am going to switch over to the console and I'll start walking through the same concepts and some examples I have set up. All right, so moving on. The AWS console was recently, I say recently, it was around reInvent last year, received an update and a new console experience. So the banner is still up here. You may see this. And what this is announcing, other than new look and feel, is a deeper integration with that fault injected injection service. So previously, Resilience Hub, it launched a few years ago, 3, 4 years ago, and it originally included all of the application resilience functionality that we'll go through. And then there was a connection to the fault injection service, but it was not as integrated as it now is, where you see your resilience management options on the left, and then also your resilience testing options on the left. So there's really those two primary aspects now. And I will walk through that both. But if you see notes about new Resilience Hub, it's really about this deeper connection and more streamlined user interface for resilience management and testing. So getting started, when you come in here and you want to add an application, one thing I will say is you get a 6-month free trial. You can do up to 3 applications at no charge during the trial. So if you want to do this, the best thing is make sure you have 3 applications in mind, and then you can get it all set up at once and make the most of the trial. The pricing after that is pretty straightforward, and I'll walk through that at the end here. But um, all you'll need to do to get started is choose how you're going to identify your resources. So you can choose resource collections, EKS, or both resource collections and EKS. The EKS options will just automatically pull in the clusters that are recognized in your region. You can also choose from these different infrastructure as code options. So you can use this for any of the stacks that you have deployed in your environment already. So you can attach this on to anything existing, assuming it was either set up through infrastructure as code or is running on EKS. Once I identify my resources, I will set a policy. And the resilience policy incorporates that RTO and RPO metric. So I'm defining these values, very similar terms and concepts that I walked through originally. These are broken down into smaller subset areas so that we know how to deal with specific types of issues, looking at infrastructure incidents, for example, versus availability zone impacts. You can see in the explanation here what the difference is the infrastructure issue could be fixed by rebooting or replacing those resources where they stand versus an availability zone issue where you have to switch to a different availability zone. So you do have the ability to more finely set these values depending on what condition is here. So you might want to have more tolerance for standing up or moving over to a new availability zone where um, you want to have a tighter time frame on infrastructure where you know that you could recognize that and issue a reboot pretty effortlessly and painlessly before you have to go recover into a new availability zone. So you can set all of these by um, by entering in the values basically from scratch uh, as you require. There is also, see how I get to it. Um, there's also an ability to create policies and save them. And so you can define, here's my warm standby policy. This already has preset RTO of 90 minutes, RPO of 1 hour. You can set those policies, um, preset them based on your application type or criticality, and then um, probably more commonly than creating a policy on the fly, you can just select the appropriate policy for the application from your list. Assign IAM role that will have access to the resources for monitoring. You can automate a daily assessment. You can also set up notifications if drift is detected. You can get an alert at a SNS topic. And then you can add the application into your environment. What you'll be left with, and I've added a few, is you have your main dashboard here, and then you'll have a list of applications. The at least the first example that I follow here is based on a Resilience Hub immersion day or workshop. So if you've ever done a workshop with your AWS account team or at reInvent or somewhere, this is a hands-on opportunity to practice and walk through these different scenarios, use the services hand-on. This follows a script for the Resilience Hub workshop that if you're interested in doing this or having your team do it hands-on, it can be scheduled and coordinated with your AWS team, and then you can walk through these same examples. Um, what this example uh, did in order to get it published. Uh, I attached to an EKS cluster and my infrastructure as code. And you can see that the service will go and it identifies all of my resources and performs that grouping that I was mentioning. So I have storage, compute, networking, and database. And I can now see um, in more detail the specific resources and then those component groupings. The application resources, once they're identified, are ready to be assessed. So the first thing I did was generate an assessment report. This is version 1. There is a new version available, but you can see all the history, and then you can actually see when the changes that I made changed the resilience posture in the environment. So when I ran my initial scan, I get uh, three main things here. I have my high level results, and then I have resiliency recommendations and operational recommendations. Resiliency recommendations are going to tell me what the recommended changes are to my environment to allow me to achieve the targeted workload numbers in that column. Right now, the estimated workload numbers are what I am able to achieve based on the resources that have been inspected. The operational recommendations are going to give me alarms, tests, and the ability to enable ongoing operations around the proper resilience for these resources. So the standard operating procedures, alarms, and fault injection tests are automatically generated for me. I can now choose one by one to implement them if I want. There are instructions for those that require some prerequisite steps. You'll get that detail here, but you can very easily select whatever components you want. If I want to just enable all of my alarms, or at least the first 10, I can select them all. Say I want to create a CloudFormation template, and this will now download that infrastructure as code template locally. I can incorporate it into my application, and I can deploy that through CloudFormation. Uh, the in this, if I switch over to my CloudFormation console, here's one recommendation that I generated that I previously deployed. So you can see CloudWatch alarm and some SSM parameters have been deployed, but without having to write any infrastructure as code on my own, it is generated for me. And so I can pull that into my environment and use it. That's going to help me to evaluate on an ongoing basis the correct posture. But first, I have several breaches in my policies. So the first thing you'll want to do is look at the resiliency recommendations here. Again, the estimated workload numbers are saying, based on the current configuration, here's what Resilience Hub thinks your estimated recovery time endpoint is. And if you see unrecoverable, that means there's not a possibility. So there's not a backup of the application. There's not another data backup. Whatever the case is, um, unrecoverable means it's not possible. But for each area where you are out of compliance according to your policy, you're given options. And the options will give you an optimization choice. So if you're looking to optimize for cost, or availability, or for the least amount of changes, needing to be made to the environment. You'll see options outlined kind of in that context. You can get multiple options, or you might get a single option where all of the optimizations can be achieved through a single set of changes. And you'll get a detailed list of what changes are required. So I should add versioning to S3. We should add an in-region AWS backup plan, and we should enable point-in-time recovery through AWS backup. So by making these changes, we are now estimating that at least my infrastructure and availability zone recovery is going from a targeted 5 and estimated of 15 minutes plus to near zero by using this configuration. Each of our areas, networking, compute, database, will have similar views. So I see my policy breached. I see the options. This has all that I can accomplish in one. And all this is saying is we need to make sure that the load balancer is configured in multiple availability zones. And again, we can fix our infrastructure um, availability. So these are all detailed explanation for that posture. I can take my recommendations, work them into my application. And in this case, I did do that. I deployed my updated infrastructure as code. I reran an assessment, and now all of my estimated numbers are falling within my targeted workload ranges. So I see all green on my reports. This report was run automatically uh, by the system you can see here. This was done because I um, I published a new build, applied a new CloudFormation change set that updated the resources, and the system knows that I've met the policies now through that automated process. I can also run assessments at any point in time if you want to make changes and test changes. You can rerun that assessment at any point, and then you'll get feedback in real time. Still, my policy is met, and no more recommendations for me. So those are my resiliency recommendations that we talked through. If we go back to, um, well, we'll go back here. So we went through the application structure. We have all our resources. We ran our assessment, now have met our different policies that we have in place. And I'll get back to the ability now to automate your alarming operating procedures and the fault injection testing. So you see a couple of alarms here now. There is a way to automatically ensure that your alarms are being consumed and displayed here. So this RDS low memory alarm was deployed as part of my original application, and is just being consumed. Essentially, I'm getting visibility through Resilience Hub. The backup job failed alarm is the one that I set up through this CloudFormation template. So that alarm is now on the implemented alarms list. At the same time, I can jump into my operational recommendations and see the list of what is not implemented. I can now choose to implement. You can group them like I did, 10 at a time, all at a time, or you can pick individual ones, create CloudFormation templates, and then deploy those along with your application. The standard operating procedures also generating CloudFormation, and this is used for more for runbook automation essentially. So when tasks need to be performed, or the automated SOPs that help you with your recovery actions, like restoring a database from a backup or restoring an S3 bucket from a backup, we can automate those SOPs using Systems Manager and automation runbooks so that as you need to recover, I now have the specific steps that I need to do that recovery and can create my cloud formation and upload those to implement them. Last thing I can do is implement any of the recommended fault injection tests. So previously I said I want to run the reboot database test and saw what happened and ensure that the database remained running. In this case, let's say I want to do my EKS stress test. I'll pick that experiment. I have, let's see, 3 different possible targets. So I'll pick my EKS deployment. I'll say I want to um, test it and I'll name it my EKS load test. You can build these fault injection tests from scratch using this builder, but the nice thing about these experiment templates is they're already pre-built based on the scenario that Resilience Hub kind of understands and automatically generated. And I can, uh, now I need to pick the actual account. So maybe I will not start this one because I don't have this value handy, but this is a good reminder that some of the targets will require permissions. So in this case, fault injection service needs permissions to be able to inject things into Kubernetes. So never mind that one, but you you see the process there. You pick the tests, you create the experiment, and this is the one I had created earlier where I targeted this specific database instance and I said my action is to reboot it. And you can see the simple reboot here. And there was no failure noted. And as you build out um, your applications and your coverage, you can use this scenario library to add on the tests that make sense from a compute or database or network stress perspective, connectivity perspective. And so each of the different scenarios you want to ensure you have adequate coverage for. And you can actually see the resources respond in real time in the environment. Then that's where this combination becomes particularly helpful. You do have to give the proper permissions for the test to run. Otherwise, you will get the failures as I was getting at first here. And um, all the testing and data overall is bubbled up to this high level summary view. Since this is a new workshop account, there's not any of this historical data for the most part loading. But if you do start using it more comprehensively, there's a lot of folks from a system reliability engineering perspective or someone from a cloud ops perspective, if you're maintaining dozens of applications, this becomes a great centralized viewpoint. Um, the last thing I'll show here before I open it up for some questions is the the score that I mentioned is here. This is broken down into more detail. You see all of the recommendations, what has been implemented, and you can track that over time. So it is helpful back to that continuous improvement perspective. It's helpful to treat this not as just a one-time thing, right? It's an ongoing thing. I've I see in my experience is much more common for people to have a backup strategy and plan in place, but it's much less common and harder to actually test that out to run through the actual process where a database goes down and we need to recover. And that can be performed much more effectively and repeatedly using the Resilience Hub service here. So um, I did set up a couple different apps. It's really flexible as long as you have infrastructure as code. I can share some of the examples and workshops that I used if you're interested in seeing more of the steps that you can run through, or if you want to schedule that with your AWS team, that is also an option. But that's a lot, I know, so I'm happy to go into more, but let me pause here, see if anyone has any questions, either in the chat or anyone wants to jump in, feel free.
Yeah. Hey, Rob, I'm going to stop recording here, and then we could open up for questions.
Okay.
All right, great.